Welcome to myprojectbazaar.com. Now we can going to discuss about the product Feedforward proportional carrier based PWM for cascade H-bridge PV inverter. Now we can going to discuss about the abstract of our project. This paper presents a feed-forward proportional carrier based pulse width modulation is proposed for DC link control of single phase cascade H-bridge multilevel PV inverter. The conventional carrier based PWM techniques such as phase shift PWM and level shift PWM require multiple levels of DC voltage controllers for individual maximum power point tracking. Thus, control structure and the controllers of design is quite complex and several non-linear carrier-based PWM techniques. This implementation of them much more complicated than those of the carrier-based PWM technique. In this paper, which propose the feed-forward proportional carrier-based PWM, each individual modulation signal directly generated by multiplying the current loop control of output modulation signal of feed forward proportional factor. In feed forward PWM and total DC voltage control as several DC voltage regulations as are achieved. These carrier based PWMs are combine the strength of both traditional carrier based PWM and non carrier based PWM. It's not only easy for implementation but also require one total DC voltage controller in outage of voltage loop then detailed description. In addition, the simulation and experimental demonstrator performs of the DC link control and individual mppt using proportional proposed PWM control strategies as per for cascade H-bridge PV inverter. These several kinds of carrier based PWM inverters are them. Next we can see about the flow diagram of our product. First we can see about the solar panel one with the mppt technique. This is one kind of solar panel with different irradiance and a different temperature. This is passed to the cascade H-bridge. Another solar panel 2 different irradiance level and a different temperature level. This is integrated to the cascade H-bridge. This also integrated to common H-bridge inverter. The H-bridge inverter passed through the AC grid. The AC grid is nothing but to store the energy of the single line of the transmission. The cascade H-bridge is some input pulses of switching characteristics of our switches. This is sinusoidal pulse width modulation to use the switching characteristics to apply on our switching pulse of our cascade H-bridge converter. Now we can see about the running process of our product. The proposed system implementation done in MATLAB version 2013A. First open the MATLAB file window and create a new model file. The creating elements as per the circuit diagram. First we can see about the circuit diagram of our product. This is a circuit diagram of our product of two solar panels used in this. This is a cascade H-bridge level inverter and the AC grid. This is an switching pulse converters. Next we can see about the results of our solar panel, cascade H-bridge inverter and the AC grid also. First we can see about the solar panel 1 of PV curve. This is an power voltage curve of our PV characteristics. Second we can see with the VI characteristics of solar panel 1. This is an 1000 irradiance and 25° temperature of solar panel 1. Next we can see about the solar panel 2. This is an irradiance level of 800 of temperature 25° centigrades of PV solar panel is an similar way to 1000 irradiance is an low to 150 volts down to the curve. Another we can see about the IV curve. This is an solar panel of IV curve. The current and voltage curves also similarly, but the voltage drop and the current curves are linear, some variations. Next we can say theoretical waveform of modulation signal. This is an sinusoidal with carry. This is a technical pulses of cascade HVDC level inverters. These are different duty cycle variation to switch on the switches. This is an solar triggering pulse and saturation region of our solar DC to DC buck boost converter level inputs. This is on some biliary variations, but shiny sharp grit. You can see that different type of triggering pulses as that. Yes, this is on solar VDC power of this wave.